Hello YouTube and welcome back. I'm Benjamin Williams and today we're within the Boson NetSim infrastructure section for studying for our CCNP Encore exam. Today we're going to be doing some NAT overloading, or also known as PAT, or port address translation. So the objective for this lab is to implement network address translation NAT and configure a simulated network to translate private IP addresses to public IP addresses that can be used on the wide area network, or the WAN. Your NAT implementation will minimize the number of public IP addresses used by hosts on the private network when accessing the WAN. You will configure NAT functionality on R4. So as we know, with the IPv4 address range, we have run out of IPv4 addresses, but NAT is able to allow us to use private IP addresses within our local area network, and then use one public IP address that everybody would use within our internal network, and that minimizes the number of public IP addresses that basically each network needs to have. So that's a way to preserve some of the IP v4 address range. So NAT was invented to do that. So if we take a look at our topology, we have R3 right here. It's connected to R4 with this point-to-point serial connection. We can see his network is 80.10.1.0/24. Don't know why we have a /24 network with a point-to-point connection, but hey, it's just a lab. And then we have our internal network right here. As we can see, it's using the 192.168.1.0/24 network within our internal. So that is a Class C private IP address range. So we have read through all of the commands and also the descriptions for this lab. I've reviewed the IP address tables for each router and each device. So we have that to reference right here as well. So let's go ahead and get into our lab task. So we're going to keep our topology up here in the top left. We're going to be doing all of our reading for our lab within the top right. And then we're going to be doing our configuration down here at the bottom. So everything looks good. Let's go ahead and get into our lab task. So it says, when configured, PAT is used to statically map multiple inside local IP addresses to a single global address. Your objective is to properly configure NAT to allow PC1 and PC3, which are hosts on the private local area network LAN, to use PAT, also known as NAT overloading, to access the public IP addresses in the simulated network. Private IP addresses, as defined by Request for Comments RFC 1918, are IP addresses that are used by networks that are not directly connected to the public internet. This RFC designates Class A, Class B, and Class C private address blocks that are available for organizations to assign to their internal networks. The simulated network in this lab uses the private 192.168.1.0/24 Class C network. In order for hosts on the private networks to access the public internet, NAT must be used. Private IP addresses are not routable on the public internet and are usually filtered by internet service providers, or ISPs. It is also a good practice for operators of private networks to connect to the internet to use filters at the network edge to prevent any privately addressed IP traffic from exiting the network. So yes, that is good information to know right there. So let's go ahead and get into task 1 of this lab. It says attempt to ping from PC1 to router 3. So as we can see, PC1 is down here and router 3 is outside on the wide area network. It has a public IP address, and basically what we're going to be trying to do is ping to an IP address out on the internet, but it's going to be filtered out basically. So let's bring up PC1. Oh, PC1. Sorry about that. All right, bring up PC1. All right, and let's try to ping to the public IP address of 180.10.1.1. And as we know, we're using private IP addresses within our internal network, so we're not going to be able to get out to the internet because we haven't configured a public IP address to use out on the internet for our internal host. So all of those pings failed. So it says on router 4, curate ACL2 and configure it to be used to select the range of IP addresses and PC1 subnet so that they will be able to participate in that. Okay, so let's go to router R4. Let's do an enable. Let's do a configure terminal, and let's do an access. Let's hit tab, access list 2, and we want to permit the 192.168.1.0 network, and we want to do an wildcard mask of 0.0.0.255. Okay, that looks good to me. Let me make sure that it wants just a standard. I think it just wants a standard, yeah, because we're using ACL number 2, so it's going to be a standard ACL. Perfect. Okay, it says on router R4, issue the command that contains the external NAT interface in the access list that enables PAC. Okay, so let's do an IP NAT. I think it's IP NAT inside. IP NAT inside. I keep hitting this this greater than key on accident. IP NAT inside source list. We want to use the source list of number 2 that we just curated. We want to do that on the interface, and we see that this interface that's going to be overloaded is the serial 00 interface. So let's go ahead and type serial 0000. Having a hard time typing today. Overload. All right, and that should be good right there. Now it says on router R4, configure NAT inside and outside interfaces. Okay, so we know that the fast Ethernet 01 is going to be our inside. So we can configure that first. Let's do interface fast Ethernet 01. And we're going to do IP NAT inside. And then we're going to do an exit, and we're going to do an interface serial 00. And we're going to do IP NAT outside. Let's do an exit. All right, so it says from PC1 and PC3, verify that you can ping R3, which it has an IP address of 180.10.1.1. So let's bring up R3, not R3, PC3, and PC1. So let's try to do that ping again, and we're able to ping R3 as we're able to see our pings are successful. Let's try from PC3 as well. Should be successful. .10.1.1. All right, and we're able to ping R3 from there as well. And it says on router 4, display the NAT translation table. NAT is configured on a router that has one interface connected to the inside local, and another interface connected to the outside network, inside global. The output of the display should show that the inside IP addresses of PC1 192.168.1.2 and PC3 192.168.1.3 have been translated to the inside global IP address of 180.10.1.2. So let's go to R4 and make sure that that is correct. Let's do an end. Let's do a show IP NAT translations. And we can see that our inside global, like it said, is not 192. Our inside global is 180.10.1.2, and that is R4 serial 00's IP address. And we can confirm that by doing a show IP interface brief. And we can see that, like I said, the serial 00 interface IP address is 180.10.1.2. So that is our inside global. And we can see our inside local 192.168.1.2. That's PC1's IP address. And we can see PC3's IP address as well, 192.168.1.3. And it's using the same IP address to get out to the internet. So that is preserving the IPv4 address ranges by using multiple inside we're using inside IP addresses for our internal network and using one public IP address to get out to the internet. So that is perfect. Let's go ahead and hit grade, and hopefully we did everything correct. And we did. So thank you guys for watching this one, and I'll see you in the next one.